I'm a chemist by trade. Um, I actually work in the education department. I've been teaching now for 8 years. So these are some of my older kiddos. Actually just hung out with some of them last week, just checking in with them. I've taught high school chemistry and physics most of the time. You can see this is an older picture, but I like to bring my kids out to the lab every year so that they can come and get a little tour of the facilities. I should update this with the students I took just last week, but instead I'm showing these old kids. So if they see this recording, they're gonna be so mad at me that they never get their moment of fame. I teach now at Synergy down in South LA. These are my kiddos last year. Again, apologies if you're seeing this, I should have updated it. But you can see, you know, we kind of fought through the COVID times. I'm sure you guys can relate. If you're teaching lab science, you're trying to get kids that are behind and get them ready for college. It can be really, really tough. And COVID was a really, really tough time to bridge a gap when the world was really trying to widen that gap. So you can see we got some time to play in the world of physics here. And I note that sweet Ashley Espinosa back here, who got the Posse Scholarship and is going to Bucknell, was clearly too cool to pose for this photo, was working hard. So I guess that paid off. Beyond teaching high school, I've also taught at the college level. So I've taught at Pasadena City College, UC Riverside, Cal Poly Pomona. I always try to like adjunct a little bit because I really like working with future teachers and future scientists. So I've taught ed classes, science classes, and hopefully soon I'll be able to work closely with you guys. So, you know, the point is that our education department is educators, right? We're not kind of in an ivory tower telling people how they should run their classrooms. We're working with teachers all the time, pre-service and established teachers, to develop content, to write curriculum, and to put together really cool stuff to get your kids really jazzed about science, right? If we want them to be future scientists, we need to bring cool science to them. And that's a lot of what we aim to do. So the NASA education team is a small group of people like me. You know, my colleague Lyle, for example, also has a scientific background, but teaches elementary school. You know, so he writes a lot more of the lessons that are standards aligned for younger kids, whereas I work a little bit more with the upper grades. But we do exactly stuff like this. We do professional development sessions. We bring you guys out to JPL. We have monthly workshops that are on lab. If you guys ever want to come and get a little mini tour, do some fun activities with us, you can kind of see like on the photo on the bottom there, that's a 30-foot by 30-foot topographical map of Mars. And we programmed little, you know, Lego rovers to kind of drive through and, you know, could they figure out a path to get from A to B? You know, so there's always a chance to just come out and do fun activities with us. Everything, like I said, is free. Everything is standards aligned. I'll probably just walk you guys through the website really quick. And of course, we have tons and tons of free swag, right? So again, if you just want some stickers or posters for your classroom, stuff like that, like I said, you'll get an email address from me. I see Gustavo is asking about where can you find this stuff? So let me transition right to that. So I'm going to put this website in the chat and then show you guys real quick. So this is the website. This is our education website. And I'll just talk about this for, I don't know, 3-4 minutes. But you can see at the top, there's a banner and then a carousel going through, like, you know, the biggest news and events on lab. If I were to, you know, answer Gustavo's question first, up here on the events section is where you'll see kind of like the big things that we're doing. These could be public talks, workshops like this one you can see here. I think this one filled up pretty quick. But yeah, I mean, monthly workshops here. You can, if you want to like get the alert so that you can be the first one to sign up, you know, feel free to do so here. But yeah, all the events windows should have kind of our goings on around the lab. The teach section is where I hope you guys will also spend some time. So if you can see here, One of the things I really like about the website, we have an amazing web designer, Kim Orr, really fantastic. What she did is she built this to be like very, very navigable so that you guys can get to the lessons you need to get to very quickly. There's hundreds of lessons and you don't want to filter through things that don't apply. As mentioned, everything's NGSS and Common Core aligned. So if you teach the standards, you can even just search for the standards right away and pull up what you're looking for. Or, again, if you're like me, you probably want to tinker through, but I know I'm not looking for a second grade lesson. I teach 11th graders and seniors. I teach physics, so let's pick a good physics one. I don't know, light and optics is a good physics topic. And now I can see just the lessons that apply to me, right? If I just pull up this first one, you'll see again, here are the NGSS standards listed for you. Everything is already lesson planned. We use a 5E model. So you'll see student worksheets are already made for you. You can just print out a PDF. Answer keys are also made. You got to be a little careful though. Your kids get smart. They'll find the answer key. So, don't show them too much. But yeah, everything's kind of already presented for you. Some background, procedure, and then of course, like some additional assessment, activities and stuff like that. If you got your high flyer kids, stuff like that. I'll actually just kind of pick another one here for fun that I can show you. And I'm picking this one just because I know it has a bunch of the additional kind of things that we do. So you can see here, same thing, standards are here, PDF. This one we translated into Spanish as well. So if you have like a high Spanish speaking population or ESL group, you'll see that we've tried to put as many of these into Spanish too. Academic Spanish is not my specialty, so bear with me. If you see errors, please tell me. And you'll also see, again, rubrics, answer keys, extensions for the kids, stuff like that. And in this one too, you'll even see, hey, this one would fit really well in like a greater unit. So if you wanted to maybe not do just one activity, but how about like a mission to Mars? Or how about an engineering challenge? Maybe something you want to do for a week or 2 weeks instead of just one day. You can say, well, cool. How would this fit into a larger unit plan for a high school class? Something like that. And they'll show you cool ways to kind of string together a bunch of lessons. And then I guess the last thing I'll say is up here in the Learn section. This was actually something we built out during COVID when we were all teaching remotely. So I don't know, we all had different situations. I don't know what yours was, but mine was I only had an hour of sync time with my students a day, which was just brutal, right? I mean, just brutal. So they were async most of the school day. So it was like, well, how do I give them projects they can do? So we started writing a bunch of lessons that students could do at home with variable supplies. Some of them are literally just paper and scissors. Some of them are, if you have a Raspberry Pi or if you have internet, something like that. But the idea is, again, student driven, you could do at home. So if I just kind of like pick a super easy one here. This is just paper and scissors. Now, instead of being in a 5E model, it's very, very, a little bit more spoon-feedy for the kids, step by step with photos. And then what I would do is I'd have kids post to our online classroom artifacts to show me that they completed the activity, something like that. Now, obviously, we're not in COVID times anymore, but I still use these activities a lot, especially for like extra credit or, for high flying kids, stuff like that, to take the lessons further. So that's kind of the rundown of the website. So let me stop sharing for a little bit and check in with you guys. So, again, these are the kind of things that we offer. I hope that you find them useful. But there's also a chance for us to chit chat about it, right? We can always go back and forth and meet and do these activities together or, with your school. So let me kind of check in with you guys. Thoughts, feelings so far. Is this useful? Is it helpful? Other than my man, Gus. Some crickets out there, my goodness. I see how it's going to be. We'll be one of them crowds, one of them teacher crowds that says, oh, why don't kids turn on their cameras and talk, and then give me that black screen treatment? Interesting. Cool. All right, yeah, good. I'm glad you guys, those who are chiming in, tell me that it's good. And again, if you ever see something that you would do differently, or if you're like, hey, I can't find something, can you help me find it? Absolutely. Happy to help. And of course, if nothing else, please feel free to just shoot me a line and say, I'm doing an upcoming unit on earth science. Can you send me some posters and stickers and stuff like that for the kids? 100%. Oh, good question. Yeah. So there are indeed internship opportunities. The problem with JPL is the age cap. So we don't have like space camp, right? That's not what we do. Like we put students to work. So as a result, they need to be effectively graduating seniors, right? They need to be on their way to college to be able to work at JPL. First of all, we can't have minors like running around. But again, if you teach fourth graders, there's just, I can't have little Timmy coding for the rover at the same time. So yeah, internships do exist, but your students got to be on the upper grades for sure. I'll point out actually, and let me share my screen again real quick. If you guys go up here to the top, there's actually an intern window. And you'll see some of the programs we have. I'll point out, obviously good on you for thinking about your kids, but think about yourself too, because we even have teacher internships as well. So there are some of these partner programs like this one here and this one here that you can apply for, right? This one is a fantastic one. This is run out of Caltech. When you actually spend the year doing research in astronomy, and you can have your students come along, right? I think they let you take a couple, like 2 to 4 students. Don't quote me if I'm wrong, but like you can pick a couple of your kids to work at Caltech with you. So again, just an amazing opportunity for young students. So what a resume line, right? Coming out of school. Let's see. Making sure I answered these questions. City, I hope I got your answer correct. And then I see a private chat. Can he attend the summer program? Any summer program? This summer is closed already. I think they open up November and December for the following summer. So everyone's already matched with mentors and positions for this upcoming summer. But yeah, take a look again in the winter for the subsequent summer. And Sean says, can we chat with some elementary kids at USC? So yeah, the best way to do that is if you go to JPL Speakers Bureau. Oops, there we go. That's what typing looks like. Right here, you can see this is like a request list. So you can fill out a little form, and JPL speakers will get an email. I do this. And you just say, hey, what time do you need someone? And it'll go out to the group. And that way you can probably get a speaker that way. A bunch of us volunteer. We're super happy to chat. So cool. I've made Sean happy, so I'm happy. And let me make sure I got everyone else. And Sean too, if you don't hear from anyone, like USC is an easy one because like you're nearby. Right. Sometimes people are like, oh, I'm trying to get you out in the IE. And it's like, oh boy. But yeah, if you don't hear from anyone, you can always email me and we'll get it set up. And let me see. College students. Yeah. And college students absolutely can intern for sure. Yeah, that's absolutely available to you guys. So on the internship page, if I go back, you'll see that which programs are open to undergrads as well as grad students. And again, for people looking to like send their high school kid out, it's really, really tough because they're in a pool with like college juniors and seniors, right? So, you know, I think the numbers we just matched everyone. I think it's 7,000 applications for every position, right? So this is a very, very competitive internship. I mean, obviously, right? Worked for NASA as a kid. So it is tough to get in for sure, but apply over and over again every summer, because why not? Why not? But you guys too, take care of yourselves. Some really cool options up here too. Did I get everyone? Am I missing everyone? I know I'm moving like a mile a minute on 2 screens. But if you guys are happy, I'm happy.
This is great. I would love to poll the audience. If you can put whether you're a current teacher or a community college student or a community partner in the chat, I'd love to be able to just see who's here.
Yeah, as you guys are doing that too, I'll say to Leah's point, like, it takes a minute, right, to get in. The first one's the hard one, but boy, after that, do they come calling? So. Beautiful, beautiful. Oh, we got quite a team here. Yeah, we got quite a team. To my people that are faculty, like, I hope that you guys will see the value in this too. Like, please promo these things. You know, I know we have community college people on the line. We have a dedicated community college program, right? So this is just for community college students. So like, I'm telling you, there's something for everyone. And like I said, once you get one of these, I mean, I had a student a couple of years ago who was like, you know, you got to help me get an internship at JPL. I was like, man, I'll try. And we couldn't get him a gig. And he ended up working somewhere else. Next year, I was like, hey man, you know, I think I can get you something. I think I saw a good thing that lined up. And he was like, boy, I don't need you anymore. He's like, I got so many options, like Yale, Princeton, all this stuff are all asking. I'm like, okay, sorry. So yeah, I'm saying once you get one, you'll be surprised at how many come together. Cool. I think I got everyone. If not, you know, please unmute or retype it if you're like, dude, you completely missed me. I'll go back and get you. Any other questions at all on the website or responsibilities, stuff like that? Oh, how did I get a job at NASA? Well, my situation was a little different. So I actually I worked in the private sector first. So I was a research scientist out of graduate school. I'm old now. That was 2009. So yeah, I worked for 7 or 8 years in the private sector first. And then as I moved, I effectively was moving into education. I was like, I'm going to give back to the community. I'm going to start teaching. And I got a call. And still to this day, haven't really figured out how, but I thought it was a prank. And it was NASA saying, you know, come work for us. Come be an educator and a scientist at the same time. And there's a world to do both. So I pretty much got in the car as fast as I could and drove to LA. So that's where I've been since. Like I said, once you get the first job, everyone else comes. You don't apply for jobs anymore. They come to you.
Brandon, you have a question in the chat. Are there lesson plans in Spanish for high school English learners?
Yeah, again, they're all going to be in English first, but you'll see that we're translating as many as we can. And admittedly, it's very slow work, but we're getting there. We're getting there. I am the Spanish translation, and boy, my accent will make you laugh. So it's slow moving. We have a lot more videos. I can do videos a lot faster than lessons. And in fact, let me put an example link in there for you, because two reasons this is faster. I can translate scripts very well and then give it to someone else to do to do the actual spoken part of it. Let me put that in the chat for you. And that way you don't have to hear my terrible accent. So things like this are a great place to start. This is, you'll be able to see everything in Spanish here. And let's see. Yeah, a couple requests for my info. You'll definitely get that at the end, no problem, as promised. And are there positions as an educator in special ed? I'm guessing, Gustavo, you mean like within NASA, or maybe you could help clarify for me. Yeah, the way our system works is the short answer is no, right? But that's not because we don't hire special ed. It's just that we don't hire. We're just so tiny, right? So the team, you've heard everyone's name already. It's me, Lyle, and Kim. There's three of us. So you've met everyone effectively virtually today. So we're a tiny team trying to do the most we can. Hopefully someday we'll expand and hire more. Cool. All right, well, I'm super happy with this. I'm glad you guys came to life. Feel much better now. You guys want to talk a little bit of science too? See some cool stuff that we're working on, and then we can maybe tie that back to some neat lessons. Let's see. What cool stuff can I show you guys? It is a good time to be in space science. I'll tell you guys that. It is a good time. All right, well, I have a ton of like demos and things here. I've like, my desk is covered with cool stuff. So I was like, oh, we'll do whatever you guys want to kind of talk about. So I think at least quickly we should make some time for this quick evolution of rovers, right? So I've mentioned in the past, for example, we got to work on the what's called EDL, entry, descent, and landing, for the Perseverance rover 2 years ago now, which was really exciting. This is a little selfie that it's taking. So you can see Percy is quite a device, right? So this is a nuclear-powered 3,000-pound SUV driving around on Mars with a chemistry lab inside of it, right? So I mean, just an absolutely wild device. And of course, in addition, it also brought with it a little helicopter, which we've named Ingenuity, which just finished its like 50-second flight. And it kind of acts effectively as a little scout. It flies up and ahead of the rover, takes pictures and says, hey, this way looks good if you want to come over here, or says, hey, maybe not so much over this way, but it gives a little bird's eye view to scientists so that the rover can kind of make a larger scale path of interest from that footage, which is pretty wild. Percy in itself brought this little rover via there it is, right? So this is what it looks like in close, and it was attached under the belly of the rover like this, right? So the Percy kind of dropped it and drove off, and then turned around and looked back at it. So that's kind of what you saw in this first picture here, right? You can see the wheel marks from where the helicopter was dropped. And then what we did is we drove a little further away, powered this thing up. So now you're seeing through the rover's eyes as this starts to test its capabilities. And then we had the first powered flight on another planet, as shown here. So you can actually see the helicopter lift up, turn around, and then kind of come back down to a nice gentle landing. So this has been so wildly successful that actually we're kind of planning on sending little scouts on future missions as well. Why not? Because it's just a great way to kind of have two robots feeding each other information. Kind of neat. To give you guys a little feel for how big this rover is, again, maybe you guys have looked up in the past Sojourner, which was the first Mars rover, is about the size of a small microwave. Spirit and Opportunity were about the size of golf carts. But Curiosity and Perseverance are big, big devices, right? So here's just a video of me turning the rover around in place. So you can see some people for scale. And what you can see is, first of all, it's real slow. We move real slow with these things because you got to be careful. You can see 6 wheels with the this kind of like gentle slope on them. We can talk more about that if you're interested. The body of the rover houses many of the instruments, and then the arm out here in the front is kind of like a chicken wing. So it stows like a chicken wing shape, but could kind of like reach out. So you can see here's the shoulder, the elbow, the wrist, and then the hand has a bunch of tools on it, including a device that will pull core samples out of the ground, right? So we're able to get chunks of rock, probably about the size of your pinky, and pull them out. And then we're going to literally shoot those back from Mars to Earth so that we can study Martian rocks more closely and more effectively, which is pretty wild stuff. Just to give you a sense for, again, and you can you don't know how big this dude is over here. So let me show you guys real quick. I have one of the wheels for you, and I'm gonna pin myself so you can see me better. There we go. So this is one of the rover wheels. So this is what it looks like in real life, just so you can get a sense of scale. Aluminum on the outside, titanium on the inside, and as mentioned, 6 of these with this kind of gentle slope. They each weigh about 40 pounds. Light but very, very strong metals, so that you can drive effectively around the surface of Mars, right? It was pretty cool. So, I mean, again, when we talk about how big these things are, right? I mean, yeah, I'm not exactly 8 feet tall, but it was quite a big device to be able to send 250 million miles to another planet. So as mentioned, in many ways, Mars pays the bills, right? It is our next nearest neighbor, and that's why we spend a lot of time exploring it. It's not that Mars is special, it's just close, right? For example, we know that Mars had water, Mars had oceans. There's still water on Mars, it's just not standing water, right? It's captured in the rocks and in mud and stuff like that. So it's a great place to look for maybe where life was. Maybe there was life in the past. That life is most likely gone, almost guaranteed to be gone. But, is it possible that at the bottom of a lake bed, there are fossils or something like this? Maybe, right? So it's kind of a cool place to explore. But I'll point out that, again, Mars is a place, but not the place, right? And as a result, I spent a lot more of my time playing on things like looking for where life would be today, right? Not in the past. An upcoming mission that might interest you guys is what's called Europa Clipper. And so Europa Clipper is a mission that's going out to a moon of Jupiter. We have 2 moons in our solar system, not here at Earth, but one at Jupiter and one at Saturn, that are actually giant floating oceans in space. Our moon is so boring in comparison, right? Our moon is a big dead rock, nothing going on there. But Jupiter and Saturn each have these moons that are liquid water underneath a thin layer of ice, right? And we know this because you can actually see these plumes of water through these cracks in the ice. It looks like this. So you can imagine, well, what if we sent a spacecraft capable of flying through those plumes of water and sampling those jets, right, that are just being shot into space to see what's inside, right? And, maybe we only learn that the ocean is salty or versus fresh or something like this, what minerals are inside. But maybe algae or bacteria are also being jettisoned out, right? How cool would that be? So to do this, you imagine, okay, well, once I figure out what that water is made out of, and I figure out a little bit more about that, the ocean, well, I don't just want to get in, like, get nearby. I want to dig into that ice. I want to get underneath. And I've been on several really cool expeditions out into the ocean where we're now testing robotics for what it would look like to explore underneath the water. So this is me next to a submersible. This is a remotely operated vehicle, so we don't go in it, but it's a prototype of an idea. What would it be like to send something that instead of driving, like the Mars rover, would actually swim underneath, right? So we got to test a lot of really cool things like that. So here you can see, this is on the EV Nautilus. This is Bob Ballard's ship, and we're testing this robotic arm. Could you like effectively sample the rocks at the ocean floor, break them, and put them into a little lab on the chest of the robot to understand more. So it's pretty cool stuff. It's kind of cool to think about. The ocean, of course, even here is wild and diverse and still like completely unknown to us. So, on these missions, we're seeing all sorts of crazy new life in just, these wild places. Remember, like, we're kilometers underneath the surface. So there's no light down there. There's only the light on the front of the rover. And you just kind of see these things in this like dark, deep unknown. And it's pretty exciting stuff. So who knows if there's still life down here that we are discovering, then isn't a place like Europa or Enceladus an even more exciting place to go see as well? Like if life isn't on Mars, fine, but life could be in Europa, could be in Enceladus. And I think that's a pretty exciting place. So let me check in with you guys too. So I'll pause for a sec. Thoughts on Mars, Europa, stuff like that before we do some last little demos and explore some more.
I'm always gonna ask a question, Brandon. You know this. When you say we're looking for life, is that in the form of like algae, like anything? Not, you think obviously like alien life form, but we're just looking for any sign of that something can exist on another planet, right?
Yeah, absolutely. When we talk about astrobiology, right? Like, there's just simply no reason to believe that life formed like us in another place. I don't even understand why life formed like us in the first place. Like I'm 38 and my back already hurts all the time. Like we are not optimal, right? Like this can't be the prime of what species should look like, So yes, we're talking about very much the existence of life anywhere, could be anything. And the ocean is just such a good place for that. Because it's not people, right? We're not looking for humans or human-like things, but we're looking for diversity. And yeah, I mean, humans are just one weird outcrop of evolution on this planet. And you look at some of the stuff under the sea, and it's like, there's got to be so much more there, right? Something that's more resistant to extremes and, can thrive in wild environments, unlike us, unlike delicate Brandon. Although if we just find another version of me, I think that'd be really interesting science too. Nightmarish for a lot of people, but now we'll start talking about like multiverses, Yeah, I think it's really cool too. Like to Claudia's point, like this isn't science fiction, right? Like students ask me all the time about aliens, and they're asking it in a silly way, but it's not a silly answer. Like it just doesn't make sense statistically that there isn't life out there. It doesn't make sense. There's got to be, right? I mean, literally hundreds of trillions of stars in the sky with hundreds of trillions of other planets, and we're the only one. It just doesn't, the math doesn't add up. So I think it's really cool to think about.
You've got a question in the chat, Brandon. How soon will we travel to these moons, and will the results be published?
Oh, thank you. Thanks, Nicole. So like I said, Mars is close. So that's the good news. Turns out, and again, this is just our solar system. We're not talking about some distant galaxy. It takes about 7-8 years to get to Jupiter. So we launch Europa Clipper next year. Stay tuned. It'll be a minute. Yeah, it's our, space is just enormous. Space is just huge. And it takes time to cross even just our neighborhood. So everything will be published, everything gets released. Everything NASA does is public because we're taxpayer funded. But it is a slow game for sure. It's a slow game. Cool. Anything else on your minds? On water worlds and Mars and aliens? Yeah, absolutely. And again, I will dork out with you guys any day you want to talk about this, but when you think about what it means to find life, how to phrase this? Don't forget that time and distance are a component, a very real component. So if you can imagine maybe 100 million years ago, which is nothing in the time frame of the universe, right? 100 million is not even a blink of an eye. There was not intelligent life on this planet, right? So maybe a passerby would have said, nothing there. I don't hear any radio signals or I don't see any spaceships. So nothing going on in this solar system, right? So yeah, time is an important factor when you're looking for life in something enormous, because life can come and go, right? The universe is, almost 15 billion years old. Do we really think that we're the first iteration? Like there was nothing for 14.999 billion years, and then all of a sudden us, like, of course life could have arisen on another planet, and it could be gone by now, right? The universe could have started and stopped many times, right? Like cosmology is a very real career. How did the universe form? How will it end? Is this the first universe, right? These are real jobs. I want kids to have these jobs. So, when we think about alien life, like we're thinking so small, right? We're thinking so small because we are so small. We got to open our minds to crazy possibilities. How have we made more advances in space than the ocean? The truth is, I don't know if that's true. I go back and forth with the ocean guys a ton about this. So they tease me all the time because they're like, oh, we don't get the funding that you guys do. And I think to myself, they're trying to map the ocean, which is only like 20% mapped, right? So like we have so far to go in terms of on mapping everything in the water. And yet we have the entire planet of Mars mapped, no problem, right? But we did that pretty cheaply, I mean, comparatively to what it costs to map the Earth's ocean. Why? Well, because I can point a telescope at it and there's no atmosphere in the way. I can send an orbiter and just kind of scan it over time. So land is really easy to do. So it's not like there's so much more money in space. And again, not to like editorialize, without like weirdos like Bezos and Musk like ruining it for everyone. But like, it's not like NASA has this wild funding that we're just out there doing space stuff and not ocean stuff. We do a ton of ocean work too. We are like the leaders in climate science data. It's just that in some ways, space is actually easier than the ocean sometimes, truly, because how do you get there, right? I can go up and float, but I can't go down and in that pressure and in that dark, and scan every inch the way I can from space. So different kind of hurdles. It's interesting though. Yeah, the space definitely sells better, right? Like kids want to be astronauts. I don't understand. And they don't talk a lot about the ocean, which I think is unfortunate. So I think we could package it better. But I don't know. I truly don't know if I believe that the advances are better in one versus the other. Cool. All right, well, I'll show you guys one more thing. I brought all this demo stuff out, so let's do like at least one more cool little demo. So let me share my screen again. So one other cool project, just since we're talking about the vastness of space that I get to work on, maybe we can do just a real quick one to play with. Is I got to work on these cool astronomy projects. One of them that I'm particularly interested in is actually this idea of dark matter. Now, if you don't geek out on cosmology the way that I do, that's totally okay. But I'm a chemist by trade, which means I went to school for 20 years, and every day I was told that this magical periodic table contained everything we knew about elements and mass and matter and stuff like that. And then I got to NASA and I found out that that was horribly incorrect, that in fact only 4% of the known material in our universe is on the periodic table. 4%. I spent 20 years trying to study. And it turns out that there's a third of the matter in our universe is what's called dark matter. We just don't know what it is. We know that it's dark. We know that it has mass because it has gravity. And that's about it. And you are now all experts in dark matter. That's what we got so far. The fact that it doesn't reflect light is interesting. We know because we can see it affect its surroundings that it must have gravity. But that's pretty much all we know. And it's really cool because Einstein effectively predicted the ways that we study dark matter long before we even knew it existed through what's called gravitational lensing. So as you guys know, Einstein, not a dum-dum, he described the universe as this kind of space-time fabric, right? And that things could effectively, with mass, could bend around, would kind of sink that fabric and cause things to bend around, including light. Light is a thing that's affected by space-time. So if a sun were traveling past another sun, you could actually see the light move around that sun. So I'll kind of show that again here. So a giant sun in the center, a passing sun somewhere, or a black hole or something with high mass, and you would actually see the light emitted by one curve around the other. And that's so wild to think about. Again, this is like a good day for us to kind of just stretch our brains, right? So you can actually see this with black holes. Black holes have much, much more mass than suns. So you can actually see this is effectively you, the observer, a black hole, and then a galaxy behind you. So you're actually seeing the light of the galaxy being affected before it can reach you as the black hole bends it around. And again, this is called gravitational lensing. It's very similar to like when you have a Coke bottle, right? You kind of see the light refract around, which is pretty neat. So now we have a means to detect heavy things by watching how light is changed, right? So you can kind of imagine it like this. If I'm sitting here on Earth and I'm trying to look at this distant galaxy over here, if I see it altered, if I see it stretched and turned, then I know there must be heavy things in between that are causing that light to curve, right? So that's kind of like a cool way to think about it. But of course, dark matter is dark. So I can't look at light the same way, but I can look at how it bends other light. So this is kind of just like a silly demo I wanted to do with you guys. I try to model this with my students. They love thinking about dark matter. So what I have for you is I have two bottles. And I believe that what you can see, undoubtedly, I'm sure you can tell, one of these has a liquid in it. You hope it's water. It could be vinegar, but let's say it's water, right? And water is going to represent my dark matter in this situation. Like, I know you can see it's there, but my question to you is, how could I prove that one of these bottles has dark matter and one of them doesn't? So I'm going to ask you guys, what can I do? What can I look for? How can I tell? How do you know one has dark matter and the other one doesn't? Gustavo says he can kind of see a line here. Let me make it a little harder. There we go. What about now? Which one has water?
Kind of going back to what you said earlier, if you were to let go of those bottles, one of them might have a different pull gravitationally.
Totally agree. Yeah, you guys can't feel
Yay!
it. Yeah, nice. You can't feel it, but if you were me, undoubtedly, you would be like, this one's heavier, right? Oh, this one's got more gravity. This one's got more mass. I agree. I totally agree. What else? What else? Nikki says the movement's different. What do you mean? I think I know what you mean, but tell me what you mean.
Would the items inside of the bottles behave differently
Ooh,
because
see that?
one has different content than the other?
Yeah. I see. So Sylvia and Nikki are getting this, right? Like I think you're totally right. So if I do this,
There you
right?
go.
Yeah, I totally agree. I should be able to see objects move differently through dark matter than if it were empty space. I agree. Yeah, totally. And there's maybe one more. And again, depending on your like kind of physics background or something like that. And I know it's a little hard to see on camera, but like there's also a quick, very simple way. You can see this has water versus not, right? And that again is refraction, right? So like you're seeing light bend differently when in an empty one versus a full one, right?
Oh, like
So
when
this is exactly right. Yeah, you guys knocked these out of the park. The three best ways to see dark matter, because since I can't see it, right, is does it bend light differently? Does it have gravity? And does it affect the way other things are trying to move through it, right? So it's kind of cool to think about. It's out there. We have no idea what its chemical composition is. We have no idea how it got there. We can't explain it, but there it is, right? And like how wild to know that hopefully after I retire, because I'll maybe lose my job, like everything that I've learned could be undone. The paradigm could completely change and chemistry could look very, very different as we discover what dark matter is. You don't know. So it's kind of neat. I truly enjoy opportunities when like the science paradigm can change, right? Science always evolving. So anyway, I just kind of wanted to model a cool demo with you. And again, to highlight, you know, tell your students careers in science are wild, right? Like again, cosmology is a profession. Thinking about these things, thinking about our universe, this is a job. You know, trying to understand the physics of dark matter, this is a job. Or if you want to be exploring the ocean and or you know planetary science and going to other planets, robots, these are jobs. So we tell kids in high school, for example, you know, you take 3 science classes, chemistry, physics, bio, and we say, what do you want to do? Like, those aren't real jobs. There's no, biologist is not a job anymore, right? Like biochemist is a job, pharmaceutical chemist is a job. Like all of these things have disciplines. And you know, we got to hype up these cool opportunities for kids. So I hope you guys found this helpful. I want to make sure I give you guys time to ask any remaining questions you have. And then I'll put my email in the chat too for you guys so you can reach out. But anything else on your minds? Anything else you want to geek out about? Science, education, internships, anything?
How does the rover or anything that you might have out there contribute to possibly finding a different or new energy source?
No, I would say not. Yeah, I would say the development of energy, whether captured or used, is definitely in a another realm. So the rover is purely exploration on a planetary side. It's doing chemistry, it's doing geology, it's doing physics. But you know, the ability to look at things like how could we harness you know, cold fusion or something like that, that's still at a very academic level. that's being, still done at the laboratory level, not at the in practice level. Some really big news out of the cold fusion world earlier this year, but long ways to go. Yeah. So still very, very much early.
Would it be possible for something to suddenly appear?
Could you be more specific?
Like maybe something may have been there and wasn't discovered.
I mean, in terms of like something on Mars or like life or something like that?
As far as some sort of usable energy
Oh,
source.
I'm imagine certainly within the realm of possibility. But again, I think we have to make sure that we invest in two paths, right? So the theoretical path is one where it's like, what could we potentially do someday if we were in a different scenario, versus what the near term is, which is like, we should probably start putting like energy into solar and stuff like that, right?
Got it. What
Or like
about the
CO2
inverse?
capture and stuff like that.
Like if we could like take stuff from here and like kind of pack it out there, like storage.
Yeah. I mean, this exists too, right? Yeah. So again, like, batteries and high conductivity and stuff like that, for sure. And again, as I mentioned, the rover is nuclear powered, right? It's thermoelectric. So
That's
it
true.
uses uranium and plutonium, right? So like, yeah, nuclear is definitely an energy source for sure.
Thanks.
Yeah, absolutely. Anyone else? Last call. Hopefully I did a good job and you guys enjoyed. Ooh. All right, well, let me put this email in the chat for you. And again, you guys saw the website and can tinker around with some activities. I'm always happy to help you guys, navigate that or look for things. Hopefully that internship information is helpful for you and your students. But keep in touch. I mean, shoot me a line anytime. I'm always glued to my email, and I'm happy to work with you guys. Cool. All right. So yeah, hopefully I get to talk to you guys soon. Thank you so much for spending your time with me, and hopefully you'll be in touch.